In this video, we're going to go over how to divide rational expressions. I gave a problem like this one just so that we review how to break up this complex fraction. So what it really means is you take the top fraction, and that's going to be our first fraction. So x squared plus 2x minus 3 over x squared plus 3x minus 4. Fractions are division. So this just means the top divided by this second fraction. And now we can go about it as we have been. And remember, we are going to be thinking some fried chicken here, and we are going to KFC the problem. So we keep the first fraction. We flip the second one. And then we change our sign. So instead of it being division, we are going to make it a multiplication problem. Now I have the problem all set up, and now it's similar to any of the multiplication problems that we have done. First thing we're going to do now is to do some factoring. All of these have A being 1, so I can just jump to looking at C. I need a number that, or a pair of numbers that multiplies to -3, but adds to 2. So x, I know I'm going to have a positive and a negative. X plus 3, x minus 1 is the first one, because 3 times -1 is -3. 3 plus -1 gets me a positive 2x. For the one below it, we see that we have x squared plus 3x minus 4. I'm looking for a pair of numbers that multiplies to -4, but that adds to 3. All right, so again, x plus 4 and x minus 1. 4 times -1, -4. 4 plus -1 is 3. All right, over here, x plus 4, I'm just going to put parentheses around it. And then I look at this -6. I need a pair of numbers that multiplies to -6, but that adds, remember, this one would be a 1, the b would be a 1, so it has to add to 1. All right, and I think that's x plus 3, x minus 2. Because 3 times -2 is -6. 3 plus -2 is a positive 1. Once I have it all fully factored, I look for ones that are the same in the numerator and the denominator. I see I have x plus 4 here. I have an x plus 4 there. I have an x plus 3 here. I got an x plus 3 here. I got an x minus 1 here. I got an x minus 1 here. Once I've matched as much as I can up, we know that we would be able to divide through by those values. I'm left with nothing but this would become 1, 1, 1, 1, 1, 1. I'm left with 1 times 1 times 1, which is 1. 1 times 1 times 1 times x minus 2 is x minus 2. So the simplified version of this complex problem or complex fraction is 1 over x minus 2. And we can also note that x cannot equal 2, because if it did, you'd have 2 minus 2. And again, we cannot have 0 as our denominator.